I welcome all of you to the class, and in today's class we will be doing the problems using the Newton's forward difference interpolation formula. And as far as the lecture is concerned, this is our lecture on right problems, problem solving, using Newton's forward difference formula. Let's have some data with which we'll be solving using the Newton's forward difference formula, and the data is, let's suppose we are given the values of x and corresponding values of y. It's x is given as 2, 2.25, 2.50, 2.75 and 3.00. Corresponding values of y are 9.00, 10.06, 11.25, 12.56 and 14.00. Okay, and the question says find the value of y at x is equal to 2.35. Okay, the question is find the y at x is equal to 2.35. See, we are given x is equal to 2.5, we are given x is equal to 2.50. Then we have to find the value of y at x is equal to 2.35. 2.35 lies here. So what is the corresponding value of y? Okay, so we are given the values of x and the corresponding values of y. Okay, so first and foremost is the question is, now we have to find the value of y when x is equal to 2.35. Before we go ahead with the solving this question using the forward difference formula, we have to draw the forward difference table. Okay, so forward difference table for this will be this is x, this is y. We will have the first forward difference, that is delta yi. I will call this as xi, this is yi. Okay, so this will be 10.06 minus 9.00, that's 1.06. Okay, second is 11.25, 11.25 minus 10.06, that's 1.19. Then we have 12.56 minus 11.25, that is 1.31. And we have 14.00 minus 12.56, that's 1.44. Okay, then we'll be taking the second difference table, that is delta 2yi, that is 1.06 minus 1.19. Okay, that is 0.13. Fine. Then 1.19 minus 1.31 minus 1.19, that is 0.12. Then we have 1.44 minus 1.31, that is 0.13 approximately. Then we'll take the third difference, that is delta 3yi. Okay, that is 0.12 minus 0.13, that's minus 0.01. 0.13 minus 0.12, that is 0.01. And the fourth difference will be delta 4yi will be 0.01 minus 0.01, that's equal to 0.02. Okay, This completes our forward difference table. Now we will use the formula. As far as the formula is concerned, the formula is, we know the Newton's forward difference formula is, using the formula of Newton's forward difference, that is y of x is equal, uh, the formula that we have is y of x is equal y of k. Okay, so where we are taking the value, that's very important for us to know. We have to find the values of x is equal 2.35. Okay, we have to find the value of y at x is equal 2.35. X is equal 2.35. This is the first entry, this is the second entry, and this is the third entry. So as far as 2.35 is concerned, it lies between 2 and 3. Okay, in the forward difference we'll be taking the value as, we'll be taking the forward difference from the second value, that is x is equal 2.35. In the same way, say for example, if we are given find the value of y at x is equal 2.60, for example, x is equal 2.60 lies here, 2.60, it lies between third entry and fourth entry. Okay, so we have to take, at that time we should take, and we have to take their forward difference from the third value. Okay, now here we have to find at x is equal 2.35, it lies between second and third value, so we'll be taking the forward differences from the second value. Okay, so our formula will be y of x is equal y2 to, y2 means the second value we are taking. Okay, we are taking the forward difference from the second entry of the table. Okay, plus delta y2 into u plus delta square yk divided by 2 factorial u into u minus 1 plus delta cube yk, or yi we should write, divided by 3 factorial into u into u minus 1 into u minus 2. Okay, the next will be plus delta 4 yk divided by 4 factorial into u minus 1 into u minus 2 into u minus 3. Okay, so this is, we have only delta 4y, so this is how the polynomial will behave. Okay, now what we will be doing is using the values we have, we are given the values, we have to find first of all the value of, we have to find the value of u. Okay, so as far as the u is concerned, our u is equal x minus x2 divided by h. Okay, as we had already done in the derivation, that u is equal x minus x2 divided by h. Okay, so we have to find the x that is given to us is x is equal to 2.35. Okay, so that is 2.35 minus x2, the point from which we are starting our interpolation is 2.25. Okay, divided by h, that will be a difference between x2 minus x1. Okay, so what is the difference in the x values? That's 2.25 minus 2. Okay, that is 0.25. Okay, that is 0.25, which is equal 2.35 minus 2.25, that divided by 0.25, that's equal to 0.4. Okay, so the value of u in all these formulas is how much? That's equal to 0.4. Fine. Okay, so now we'll be substituting the value of u in these formulas, in the given formula, to obtain the value of y of x. Okay, so it will be for us, let me complete it here, y of x will be equal, first of all we have y2. Okay, when we write y2, the value of y2 is 10.06. Okay, so it's equal 10.06 our y2. Fine, plus this is y1, this is y2, this is y3, so on, plus delta y2 into u, this is delta y1. Okay, this is delta y2, this is delta y3, this is delta y4. So we have delta y2 into u, delta y2 is 1.19. That's 1.19 multiplied by u, that is 0.4, plus delta 2 y2 divided by 2 factorial. This is delta 2 y1. This is delta 2 y2. Delta 2 y2 is 0.12. So we'll write 0.12 divided by 2 factorial into u. U is equal to 0.4 into 0.4 minus 1. Okay. And the third term will be delta cube. This is y2. Okay, because we're taking forward difference from the second entry. So delta 2 y2 is how much? That's equal to 0.12. Okay, so we'll write plus 0.12 divided by 3 factorial into u, that is 0.4, into u minus 1, that is 0.4 minus 1 into 0.4 minus 2, plus. So we have delta 4 y2. What is delta? This is delta 4 y1. Okay. Then we have delta 4 y2. That's equal. There is no entry. That's equal to 0. Okay. So this entire term becomes equal 0. Okay. So the expression will be, the expression for this will be, on solving this, so y of x, so this is y we are finding at x is equal to how much? At x is equal to 2.35. Okay, now we have to solve this. 10.6 plus so on, this becomes equal uh, 10.522. Okay, so the value of the x, so the value of the y at the given value of x, so when the value of x is equal to 2.35, the value of y is 10.52. Okay, since everything is given up to 2 decimal places, I will also write it up to the 2 decimal places. Okay, in the same way, so we have solved it. For x is equal to 2.35, the value of y is 10.522. Okay, so let's solve one more problem on forward difference. We are given the values of x, xi. We are given the values of y as yi. Okay, so the values of x are like 1, 3, 5, 7, and 9. The values of y are 2, 3, 9, 6, 8. Okay, so we are asked to find the value of y when x is equal 6. Okay, so when x will be 6, what will be the value of y? Okay, so you see, as we go ahead, we have to find the value of y at x is equal to 6. X is equal to 6 lies here. This is your first entry. This is entry 1. This is x1. This is x2. This is x3. This is x4. This is x4. Sorry, this is x4. We have x5. Fine. Now we have to find the value of y when x is equal to 6. X is equal to 6 lies between third and fourth entry. So we'll be starting our interpolation from the third point. Okay, so first we have to draw is the forward difference table, that is delta yi will be 3 minus 2 is 1, 9 minus 3 is 6, 6 minus 9 is minus 3, 8 minus 6 is 2. Okay, this first entry is known as delta y1, this is delta y2, delta y3, delta y4. Okay, in the same way, take the second entry values, that is delta 2 yi, that is 6 minus 1 is 5, minus 3 minus 6 is minus 9, and 2 minus minus 3, that's equal to 5. This is delta 2 y1, this is delta 2 y2, this is delta 2 y3. Then we take delta 3 yi. Minus 9 minus 5 is minus 14, and 5 minus 9 becomes equal, 5 minus minus 9 becomes equal 14. The fourth entry is delta 4 yi. That is 14 minus minus 14, that becomes equal 28. Okay, now what we will be writing is y of x. Okay, so we write it as the polynomial that we have. So our interpolation starts at, we have to do our interpolation for at from which value forward difference will be taken from the third value. So the formula becomes y of x equal y3, okay, we're taking from the third value, plus delta y3 into u plus delta 2 y3 divided by 2 factorial u into u minus 1 plus delta 3 y2 divided by 3 factorial into u minus 1 into u minus 2 plus the fourth entry will be delta 4 y2 divided by 4 factorial u into u minus 1 into u minus 2 into u minus 3. Okay, so first find the value of u. U is equal x minus x3 divided by h. Our x is equal to 6 minus x3 is equal to 5, and the distance between the corresponding values, 3 minus 1 is 2, 5 minus 3 is 2, that's all equal to, okay, that becomes equal to 0.5. So put the values. As far as y3 is concerned, y3 is equal to 9 plus delta y3 into u. This is delta y1, this is delta y2, this is delta y3, that's equal to 5 into u is 0.5 plus, then we have delta 2 y3. Sorry, here it is. This is delta y3. This is delta y1, delta y2, delta y3 is minus 3. Then we have delta 2 y3. This is delta 2 y1, delta 2 y2, delta 2 y3 will be equal to 5 divided by 2 factorial u, that is 0.5 into 0.5 minus 1. Okay, then we have plus delta 3 y2. This is delta 3 y1, this is delta 3 y2, that is, so it becomes 14 divided by 3 factorial, okay, 0.5 minus 1 into 0.5 minus 2. Then we have delta 4y2. We do not have delta 4y2, therefore this entry goes. The entire expression becomes equal 9 minus 1.5. Then we have minus again. That's equal 0.5. That is minus 0.5 minus 0.5. So it is 2.5 into 0.5 into 0.5 plus 14 by 6 into 0.5 into 0.5 and 1.5. Okay, this is minus, that will be altogether plus. So on solving this expression, we'll get the value of y at x is equal 6. Okay, so we can now easily solve it. So this is how to solve the basic questions on they're using the Newton's forward difference interpolation formula, and I encourage my students to solve this problem at their places. It is xi, this is yi, xi is 1.0, this is 3.62, this is 3.0, 5.0, 7.0, 9.0. Okay, this is 4.33, this is 5.12, this is 7.61, this is 4.28. Find the value of y at x is equal to 8. Okay, so when x is equal to 8, find the corresponding value of y. This is to be solved using Newton's forward difference table. This completes the course on forward difference table, and in the next class we'll be talking about the curve fitting. Thank you very much.